Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we are explaining about assignment part 2, work and energy and impulse and momentum for subject BMFA 2123 Dynamics, semester 1, session 2021-2022. We, proce- we proceed with the first question. The question states that the object from part 1 is released from rest and slides down along the smooth ramp as shown in figure 1. Given y naught is taken from the value in part 1. For question A, sketch the free body diagram of the object. This is the free body diagram sketching, which this a normal force and is a weight of the object. For the next question, calculate the speed of the object just before it leaves the surface at B. So here we take kinetic energy at A plus potential energy from A to B equals to kinetic energy at B. The formula for kinetic energy at A is half mv squared at A plus mgh for the potential energy equals to half mv squared at B. So here, because of the object starting from the rest, there's not any velocity at the starting point, so we cancel the velocity at A, so it's become 0. Then because this mass is equal, so there's no any, we cancel out these two mass, and just leave GH, GH equals to half VB squared, and we calculate, we get VBH equal to 7.035 meter per second. Okay, for the next question, calculate the distance from the wall of the ramp at B to where the object strikes the ground. So the first formula we use here is x ground equals to x naught plus VBXT to find the x here. Then first x ground equals to x naught plus VBXT. X naught is 0 because the initial x here is 0 plus VBXT. From the previous calculation, we got VBX equal to 7.0035 T. Then to find T, we need to find by using this equation. By this equation, y naught equals to yb plus vbyt minus half gt squared. Y naught is negative 1 because this y naught is here, which is 1. So y naught is when the objects falls down, it becomes negative 1 from the 0. From here to here is 1. So here this is the origin. Because this is the origin, the y naught becomes negative 1. Then yb is 0 and v from b to y equals to 0 minus yb equals to 0 plus vb at y axis equals to 0. So t also will be 0 minus half gt squared, 9.81 t squared. Then we get t equals to 0.4515 second. Then we substitute t value to the equation. X ground equals to x naught plus vbxt. Then we get the x ground equals to 3.1621 meter. Okay, next, compute the speed at which the object hits the ground. We use the formula of kinetic energy at A. Here is A. A is here. Then plus potential energy from A to C. C is here. Equals to kinetic energy at C. The kinetic energy at A is half mv squared plus potential energy A to C mgh equals to kinetic energy half mv squared. Because the initial velocity of the object at A is 0, so we cancel the velocity, becomes 0. Then the mass this mass and this mass is same, and we cancel each other, and we just left gh equals to half v squared. Then until we get the final answer, the speed at ground equals to 8.2867 meter per second.
Okay, we continue to the question 2. The object from the part 1 release from the rest and slide down along the smooth ramp as shown in figure 2. Assume y not equal to 1 meter if y not equal to 0 in part 1. The horizontal velocity v1 is equivalent to the speed of object just before it leaves the surface at B. Take the E equal to 0.7. Okay, the first question for the question 2 is calculate the velocity of the object just after its rebound from the ground. The object, the velocity of the object after rebound of ground is this one, the VCY2, then in this one VCY is the object when it's hit the ground before the rebound. Okay, if you want to find this VCY2, the speed of object after the rebound, we must use this equation. E equal to VB square VB2 minus VA2 divided by VB1 minus VA1. This equation is equation defining the coefficient of restitution E. Okay, the E is given 0.7 equal to 0 because the VB is from initial, minus VA2. VA2 are what we want to find, and VB is we must find first because we don't know VB. Minus VA1. VA1 is after rebound, is go to the horizontal back. Uh, VB1, we want to find this VB1, we use this equation. VCY square equal to VY rebound square plus plus 2AC in bracket S ground minus SB. VY rebound is 0 because it's from the initial, we assume as the 0 plus 2 in bracket negative 9.181 is the deceleration, and S ground 0 minus SB is negative 1 because is because it's down from the origin. Okay, the answer is equal to negative 19.62. But this is not the final answer. We must to square root this answer. We transfer the negative to the left side and we square root the answer, and we get the VCY equal to negative 4.4294 meter per second. Is same answer to VB1, what we want to find, VB1. After that, we take this answer and we derive to the E equation, and we can find the VA2 is equal to 3.1006 meter per second is VA, or we call is VCY2. Okay, the question for the question 1 of the first question for the question 2 is not finished because we must find the magnitude of VC2. VC2 is equal to 7.0035 square plus 3.1006 square is equal to 7.6592 meter per second. Okay, continue to the second question for the question 2. Compute the maximum height to the which of object rises after the first bound. Okay, the the height of the maximum height is right here. This one is h, and then this one is sy is 0 from the origin. Okay, the equation we derive back. VCY1 equal to 0 because it start from the origin, equal to 3.1006 is the VCY we find from the another slide, plus 2 in bracket negative 9.81 for the acceleration, and bracket h minus 0 because the sy is 0, and we get the 19.62 h equal to 3.1006 square, and h equal to 0.4900 meter. Okay.
So that's all from us. Thank you. Hope we will see you again. Assalamualaikum.